Welcome pre-cal students to the homework help video. The assignment is here in front of you, and let's go ahead and get started. First of all, number one looks a little confusing, but it's not that difficult. What they're basically saying is take this function right here that I'm circling in black, and they're saying for number one, just simply solve it equal to 0. So they want you to simply take this equation, set it equal to 0, and solve. So we can do that pretty quickly. That's not too difficult. Okay, if we want to solve an equation like this, we should know by now that we're going to try to factor, and factoring is definitely something we can do here. X plus 5, x minus 3, 5 times negative 3 is a negative 15, and when you combine those you get positive 5. So negative 5 makes this parentheses equal 0, and a positive 3 makes this parentheses equal 0. So there, number one was pretty easy. They just wanted us to solve the equation for 0. Now that we've done that though, don't forget these numbers are really our critical values. So I'm going to go ahead and put negative 5 and positive 3 up here, because now look at number 5. Remember, we're doing every other odd. We did number 1, so now let's do number 5. Notice here's what they want you to do for number 5. They want you to take the entire function and set it greater than or equal to 0. So forget this right here. There we go. So now you should know from the notes, if you have a polynomial greater than or equal to 0, you first set it equal to 0 and solve and get your critical values. But we did that right over here. So let's go to a number line. We'll put a 0 here. We'll put a negative 5 here. We'll put a 3 over here. And then let's go ahead and look at our sections. We have a section over here. And by the way, these points should be closed because the symbol right here says greater than or equal to. And then of course we have a segment right here between the 5 and the 3. And then we have 1 over here to the right. So very quickly, if we test a negative 6 right here, we're going to get, let's see, 36 minus 12 minus 15, and that's going to give us 36 minus 27, 9 is greater than 0. 9 is greater than 0. And that of course is true, so this segment right here does check. Now let's go ahead and for our middle section here, let's substitute 0 in and let's see what we get. 0 squared is 0, 2 times 0 is 0, minus 15 greater than 0. Well, negative 15 is not greater than 0, so this segment does not work. Now let's try the one to the right over here, and we're going to test 4. Let's test 4. Well, 4 squared is 16. 2 times 4 is a positive 8. Minus 15 is greater than or equal to 0. Let's see, 24 minus 15 is 9. 9 is greater than 0. So this section here, or this region, checks. So our answers using interval notation would be negative infinity up to negative 5 inclusive, so use a bracket. And then of course we have the number 3, which is where this region starts, going to infinity with a parentheses. Okay, so there's your two answers. Okay, let's go ahead and take a look at number 9. Now number 9, they just simply want us to take g of x, which is right here, x to the 5th power minus 9 x to the 3rd, and they want us to do what number 9 says, set it greater than 0. So we should know how to solve this. I mean, we did just take notes on this. The first thing you do is you rewrite it with an equal sign. So x to the 5th minus 9x cubed equals 0. Next we factor, so we're going to pull out an x cubed, and we're left with x squared minus 9, and then we're going to factor the x squared minus 9, and that's going to be x plus 3x minus 3. Now for this group right here, we get a 0. For this group here, a negative 3, and for this group here, a positive 3. So there's your 3 critical values. Okay, so let's quickly slide this up for a second, shrink this down a little bit, pull this up here, And now we can erase this. So our critical values are 0, -3, and +3. So here we go. 0, 3, -3. They will all be open points. Now let's first of all check our region over here to the left. Okay, let's use a -4. Well, a -4 to the 5th power, I don't have a calculator in front of me. 4 times 4 is 16, 64 times 4 would be 256 times 4 would be 24, 22. I think it's 1,424. Although remember, it is a -4, and a -4 to the 5th power would be a negative number. And then if we put a -4 in here, 16, 64, we would get a -64 times a -9, which would be a positive 36, not even close to this. So if you do simplify all this, you will see you get out a negative number is greater than 0, and there's no way a negative number is ever greater than 0. So this segment here, or this region here, does not work. Now let's go ahead and try this region right here. I guess the easiest number to test would be a -1. Okay, so let's test -1. If we take -1 to the 5th power, we will get a -1. -1 to the 3rd power is a -1 times a -9 is a +9. And so we end up with 8 is greater than 0, which is true. So this section right here does check. Okay, now let's test the number 1, +1. So let's see what happens. We're going to test 1 for this region right here. And let's see what happens. 1 to the 5th power is 1. 1 to the 3rd power is 1 times -9 is -9. And so we end up with -8 is greater than 0. And that is not true. Okay? And now let's continue on to our last section right here, going this direction. And the obvious number to use would be 4. So we're going to substitute 4 into our inequality. And let's see, 4 to the 5th power again would be whatever it was I said. 64 times 4 was 256 times 4, 24, 22, 1024. Positive, and then 4 to the 3rd power is 64 times 9 would be, I'm not sure it's a negative number, but it's definitely less than 1024. And so you do end up, if you'll simplify all that with the calculator, you will see that you will get out a positive number is greater than 0. And that's true. A positive number is always greater than 0. So this section right here does work. So we have this region here that works, and this one here. So for this region right here, your answer would be -3, 0, just like that. Non-inclusive, so we use parentheses. And then over here, our answer would be 3 to +infinity. So there's our two answers, okay? All right, moving on now to number 13. All right, here's number 13. Now, number 13 is actually pretty easy because if you'll look, students, and just think about it, you have no critical values to find. They're already found for you. I mean, here they are. Remember, when you're dealing with a rational function, your critical values are the x-intercepts and the asymptotes. So you have a critical value here, -3 it looks like. Let's see. No, 2, 4, they're in increments of 2. So -2. And then you have an x-intercept at 0. And then you have a asymptote at +2. So really, to be honest with you, you already have your critical values. They're -2, 0, and +2. So with that in mind, there's really not a lot of work to do, except just substituting values in. So we'll start off with this region over here to the left, and we're going to test -3. Well, 8 times -3 is -24. -3 squared is 9 minus 4 is 5. And -24 over 5 is going to be a negative number, and a negative number is never greater than 0. So we're going to cross that off. It did not work. All right, let's go ahead and try the next region, and we're going to test 1, okay? We're going to test 1 right here. Well, 8 times 1 is 8. 1 squared is 1 minus 4 would be a negative 4. So we're going to get out a negative number, and a negative number is never greater than 0. So this segment here, this region here, does not work. Now let's try this region right here. Okay, let's go ahead and substitute 1 in. Well, 8 times 1 is 8. 1 squared is 1 minus 4 will give you, let's see, and actually, I want to go back to negative 1, and I apologize. I just seen something I made a little mistake on. I apologize. When we tested negative 1 here, right here for this region, 8 times negative 1 is negative 8, and then 1 times 1 minus 4 is negative 3. So a negative over a negative does give you out a positive number, and that is greater than 0. So I apologize. This region here does work. Okay, the one in red that I'm circling over and over. Okay, now if we test 1 right here in this section, 1 will not work. And if we test 3 in this region here, 3 should work. 8 times 3 is 24, and 3 squared is 9 minus 4 is 5. 24 over 5 is definitely greater than 0. So this segment right here also works. So the answer to this, oh, and by the way, our points should be closed. All of our critical values should be closed points because of this greater than or equal to right here. So for this segment right here, your answer would be negative 2 on up to 0. Both are brackets inclusive. And then this one over here would be positive 2 going on to infinity. All right, moving on to number 17. Okay, they want us to solve this inequality. So step 1 is to rewrite it with an equal sign. So next we would write x minus 4, x plus 2 with an equal sign, and then we're going to solve it. However, when you go to solve this, notice it's already factored for you. This is so easy. So we know the number that satisfies this parentheses would be a positive 4, and the number that satisfies this parentheses here would be a negative 2. So there's your two critical values, 4 and negative 2. So the next thing we do in these problems is we put those critical values on a number line. Here's 0, here's 4, over here is negative 2, and because of the equal sign right here, we do close both of these points. All right, now let's start off with this section over here. We'll call it a black section, and we're going to test negative 3. Well, negative 3 and negative 4 gives me a negative 7. Negative 3 plus 2 would be a negative 1. And when you multiply negative 7 times negative 1, you get a positive 7. Positive 7 is definitely greater than 0. So that section definitely works right here. Now let's try the section here between the 2 and the 4. Let's test 0. Put a 0 in for x. 0 minus 4 is negative 4, and 0 plus 2 is 2. And a negative 4 times 2 is a negative 8. Negative 8 is definitely not greater than 0. So that segment there, that section or that region, does not work. Now let's go ahead and try this one to the right over here, and we're going to test 5. Okay, so 5 minus 4 is 1. 5 plus 2 is 7. 1 times 7 is 7. 7 is definitely greater than 0. So this section here does work. So your final answer would be this. This is an unbounded region over here, so we're going to say negative infinity to negative 2 inclusive. And then over here we're going to say starting with 4 and going to infinity, and non-inclusive but inclusive with the 4. Okay, so that's number 17. Moving on to number 21. Number 21, okay? The first thing we do is we replace the original problem with an equal sign, and then we're going to bring the 25 over and make it a negative 25. And now we're going to solve this. And of course, we would factor x minus 5, x positive 5 equals 0. Now, the number that satisfies this parentheses would be 5, and the number that satisfies this parentheses would be negative 5. So there are our two critical values that we're going to use, positive and negative 5. Okay, so let's quickly put those on a number line. Here's my 0, here's my 5, here is my negative 5, and both of these points will be open. And let's go ahead and test this region here first, or this section going to the left. We're going to test negative 6. Well, negative 6 squared is 36, and 36 is greater than 25, so this section here does work. Now let's check the section between negative 5 and 5. We're going to test 0. 0 squared is 0, and 0 is not greater than 25, so this section here does not work. And then lastly, we're going to test 6 right here for this last section or region, and 6 squared is 36. 36 is greater than 25, so this section here does work. Okay, so the two sections that work are here and here, and so let's go ahead and write our answers. For this section right here, it would be negative infinity going to negative 5 non-inclusive, so we use a parentheses. And then for this section over here, we're going to start with let's see, 5, and we're going to go to infinity, and the 5 is non-inclusive, and of course infinity always gets a parentheses. Okay, so there we go. There's our answer for this polynomial inequality. All right, let's move on to number 25. Okay, let's solve this like all the others. First of all, we're going to set it equal to 0. And when I do that, I'm going to go ahead and write this in standard form. I'm going to put my negative x squared first, my positive 6x second, my negative 9 third, and then equals 0. Now, I never want to try to factor when this first term is negative, so I'm going to pull a negative sign out, and that's going to leave me with x squared minus 6x plus 9. And now I can factor that pretty quickly. What two numbers when added together give me 9, or when multiplied together give me 9, when added together give me a negative 6. Well, that's going to be a negative 3 and a negative 3. Now, you say, Mr. Art, what about this negative sign here? Well, guys, look, this negative sign really doesn't matter here because there's no x with it. Now, if there was an x there, a negative x, then the number that would satisfy this group would simply be 0. Okay, but there is no x with the negative sign, so it's really not a big deal to us. Now, what satisfies this parentheses here is the positive number 3, and what satisfies this parentheses here is also positive 3. So we really only have one critical value, and the critical value is 3. Okay, so that's not too difficult. So we're going to take that critical value, and we're going to go ahead and put that on a number line. Put a 3 here. I guess we'll put a 0 right here. And there's our one critical value. Notice it is an open point because there is no equal sign under the inequality. Well, let's go ahead and test the section going to the left. I guess we'll check 0. 0 here is a 0, then minus 9, 0 squared is 0, so minus 0, less than 0. So negative 9 is less than 0, so this section here does check. Now let's try this section over here. Let's go ahead and try a 4. All right, let's try the number 4. Well, 6 times 4 is 24, minus 9, and then 4 times 4 is 16, so minus 16, less than 0, and that would be 24 minus 25, which is negative 1, and negative 1 is definitely less than 0. So this section here also works, okay? So really the only thing that doesn't work is the number 3, all right? So with that in mind, all that we're going to say is the answer going here to the left is going to be negative infinity going up to 3 but non-inclusive, and then we're going to start at 3 and we're going to go to the right, which is infinity, and there we go. So the real answer is every real number except for 3. All right, let's take a look at number 27. I'm going to grab, or number 29. I'm going to grab a quick drink here. And let's go ahead and get started. I'm going to do 2 steps in one. The first thing I'm going to do is bring all of the terms over to the left side. And then I'm also going to set this left side equal to 0. Now let's quickly solve this. We can pull an x out. So we're left with 4x squared minus 7x minus 15. And then next, because I do not have a lead coefficient of 1, I have a lead coefficient of 4. I take 4 times negative 15, that's negative 60. And I'm trying to think of two numbers when multiplied give me negative 60, when combined give me a negative 7. And I believe that's going to be negative 12 and a positive 5, okay? So I'm going to go ahead and put an x, and then I'm going to put 4 terms here, 4x squared. I'm going to go really fast because we know how to factor these. We have done 100 of these since the school year has started, at least. And so let's see here, pull out what's common in the first two. That's 4x, leaves me with x minus 3. Pull out what's coming here, that's a 5, leaves me with x minus 3. And so the final factorization will be x, and then your matching parentheses, and then 4x plus 5 equals 0. All right, so there we go, good enough. There's our complete factorization. Let's go ahead and do a little bit of deleting here so we have some room. And now let's quickly find our critical values. The number that satisfies my first group here is 0. The number that satisfies this group is 3. And if you were to set this equal to 0 and solve, you would get negative 5/4 or negative 1 1/4. So there's your critical values, okay? So I'm going to go ahead and put my number line right here. Here's 0. Here's 3. Over here is negative 1 1/4. And all of these points will be closed points because of the equal sign right here under the inequality. All right, so there we go. Now let's get rid of all of this. Let's pull this up so we have a little bit of room to write things, and let's get started. Let's first of all test numbers to the left here. If this is negative 1 1/4, I'm going to test negative 2. So negative 2 to the third power is negative 8 times 4 is negative 32. Negative 2 squared is 4 times 7 would be negative 28 is less than or equal to negative 30. Well, that's definitely true. You're going to get something like negative 60 over here is less than negative 30, and that's definitely true. So this section here does work. Now let's check, I guess what, a negative 1 would work for this section here. So let's test negative 1. Negative 1 is definitely in between 0 and negative 1 1/4. So negative 1 to the third power is negative 1 times 4 is negative 4. Negative 1 squared is 1 times 7 is a negative 7, less than or equal to negative 15. And that is not true. Negative 11 is not less than negative 15. So this section here that we just tested does not work. And now we'll test a 1 for this section right here. We'll test the number 1, and 1 to the third power is 1 times 4. 1 squared is 1 times negative 7 is negative 7, less than 15. That's true. Negative 3 is less than 15, so this section here does work. And then lastly, we will check this section here to the right, and we'll use 4. So 4 to the third power is 4 times 4 is 16, times 4 is 64. Times 4 would be 256. And then 4 times 4 is 16, times 7 would be 112, so minus 112 is less than, and then 15 times 4 would be 60. Well, there's no way that's true. 256 minus 112 would be 100 and something is less than 60, and that is not true. So this section here does not work. So with that in mind, let's write our final answers now. For this unbounded region over here, we would say negative infinity up to negative 5/4 or 1 1/4 inclusive. And for this bounded region, we would say 0, 2, 3, and it is inclusive. And there we go, we're moving right along, okay? Let's take a look now at number 33. Number 33. Okay, I'm going to go ahead and do two steps at once. I'm going to bring the 5x over and make it a negative 5x, bring the 6 over and make it a positive 6, and go ahead and set it equal to 0. All right, and this should be an x to the third. Now the first thing you should notice as you go to solve this for 0 is that you cannot factor this. If you pull out what's common in the first two, terms, and then pull out what's common in the last two. Your two parentheses do not match. So we cannot factor this, so we're going to have to list out all the possible rational zeros and start testing them. Now I am going to try to save a little bit of time and tell you right now one of the zeros for this would be -2. So I'm going to quickly use synthetic division and see what I'm left over with. Bring down a 1, multiply -2, combine, multiply 8, 3, and -6. Now what you're left over with is x squared minus 4x plus 3. And that can be factored because if you take -3 and -1 and multiply them, you'll get a +3. And if you combine them, you'll get a -4. And so your factorization would be x minus 3, x minus 1. So one zero is -2, the other one is +3, and the other one is +1. And it's a third degree, so we know that's the most possible amount of zeros we can have. All right, so there are our critical values. Now you might say, Mr. Earhart, you kind of cheated. You knew what zero to start off with, and I would say that you're right. That's true, but I am trying to save time on these videos, and also hopefully we know by now how to test all of those zeros until we find one. Okay. All right, all of your critical values will be open points, and let's quickly get started. Let's go ahead and test a -3 into this. So -3 to the third power is -27. -3 is 9 times -2 is -18, less than -15, -6. Well, that's true. You're going to get -45 is less than -21, and that of course is totally true. So this section right here does work. Now for this region here, let's test 0. So 0 cubed is 0, 0 squared times 2 is 0, 5 times 0 is 0 minus 6. So we end up with zeros less than -6. And that's not true. 0 is greater than -6. So this section here does not work. Now let's test this region here, and we're going to use the number 2. Well, 2 to the third power is 8. 2 times 2 is 4 times -2 is -8, less than 5 times 2 is 10 minus 6 would be 4. So 0 is less than 4, and that is true, and so that section there does work. And then lastly, we're going to test the number 4 for this region right over here, this section, and 4 to the third power is 64. And then 4 times 4 is 16 times a -2 is a -32, less than 20 minus 6. And that's just not true. You're going to get 32 is less than 14, and 32 is not less than 14. So this section over here does not work. So for this region right here, you would say negative infinity up to -2, non-inclusive. And then for this section right here, we would say non-inclusive of 1 all the way to 3, non-inclusive. And there would be your answer. Let's move on to number 37. Okay, number 37 looks like the same kind of problem. So we're going to go ahead and do 2 steps in one. I'm going to write 2x cubed, then bring the 5x over and make it a -5x squared, then bring the x over and make it a -x, and then leave the 6 positive and set that equal to 0. Now trust me, if you were to try to factor this, you would not be able to, and you would have to list out all the possible rational zeros. Now when you do that, and again I know I'm cheating a little bit, when you do that, you're going to have to test a lot of numbers, and I know that can be frustrating, but here on a video there's no need for me to test all the numbers and show you which ones don't work. So instead I'm going to show you one zero that does work, which is -1. So let's quickly use synthetic division, and first of all we're going to check and make sure it's a 0, and then secondly we're going to be able to reduce our third degree polynomial down to a second degree. So we'll bring our 2 down, multiply, it's a -2, combine we'll get a -7, multiply we'll get a +7, combine we'll get a +6, and -1 times 6 is -6. So we did get a 0. What we're left over with is 2 2x squared minus 7x plus 6. Now I believe that's factorable. If you take 2 times 6, you will get 12. And if you then multiply negative 3 and negative 4, you will get 12. And if you combine those, you'll get negative 7. So moving very quickly now, because we have definitely factored a lot of these this year, let's go ahead and remember that one of our zeros is a negative 1. Okay, let's not forget that. And then let's quickly factor this. So 2x squared minus 3x minus 4x plus 6 equals 0. Pull out what's common over here, and it should be an x, so we're left with 2x minus 3. Over here it's a negative 2, and we should be left with 2x minus 3. Let's check and make sure that's right. Negative 4x, positive 6. And so our matching parentheses would be 2x minus 3, and then x minus 2. So here's one critical value over here. Now the number that satisfies this parentheses here, or this group, would be 3 halves, or 1 and 1/2. Okay, and of course 2 satisfies this group right here. So there are your 3 critical values. Now let's test those, or let's put those on a number line. Here's 0, here's negative 1, here's 1 and 1/2, and then here's the number 2. And all of these critical values will be closed points because there is an equal sign right here. Okay? Well, the first number I'm going to test in this region over here will be negative 2. And let's see what happens, okay? If we put a negative 2 in, we will get a negative 8 times 2 is a negative 16, plus 6, less than or equal to. Put a negative 2 here, that's 4, that's 20, plus a negative 2. And so we end up with negative 10 is less than or equal to 18, and that's totally true. Negative 10 is less than 18. And so this first region here does work. Now for our next section or region right here, let's test 0. Well, 0 cubed times 2 is 0 plus 6. 0 squared times 5 is 0 plus 0. And we end up with 6 is less than 0. And that is not true. Okay? That is not true, so this section does not work. Now let's go ahead and try this section right here. Unfortunately, we're going to have to use something like 1.75, or in other words 1 3/4. And just saving a lot of time and not trying to use all those decimals, you do understand, students, that would pretty much be a calculator problem. 2 parentheses 1.75 to the third power plus 6 less than or equal to, etc., etc. You will get out a true statement that does check, and feel free to check that. Take your calculator and type all that in. You will see it does check. Okay, and then we have to lastly check this last quadrant over here to the right, and so we're going to use 3. Okay, we're going to check 3. Well, 3 to the third power is 27 times 2 is 54. So 54 plus 6 is less than or equal to. And we'll put a 3 here. 3 squared is 9 times 5 is 45 plus 3. So we end up with 60 is less than 48. And that is not true. So the two regions that work are the two circled ones. So your answer would be negative infinity to negative 1. That would be inclusive. And then the other section is a bounded section. It would be inclusive 1 and 1/2 to 2. Okay, so there's the answer. Let's move on to number 41. Number 41. Now, don't forget, when it comes to rational inequalities, there are two different types of critical values. One type is when you take the equation, like I'm doing now, and you set it equal to 0, and you solve that. So I'm going to multiply the entire equation by x plus 4 over 1. Okay, now when you do that, this cancels, and this cancels here. And you're left with 1 over 1, so you're left with 1 equals 0. Now students, there's no x's left. Everything canceled out, and you're left with a false statement, 1 equals 0. Now what that means is there's no solution. In other words, are you listening? There is no number that you could put in for x that would ever make this equation equal 0. Look right here. There is no number you could put. You can try as many as you want. You can try a million different numbers. There is no number that you could put in for x here that would make this whole fraction become 0. There is nothing. So there's no critical values when it comes to solving this equation. Now the other type of critical values is looking at each fraction and asking yourself, what makes this fraction undefined? Well, what makes this fraction here undefined is a -4, because a -4 plus 4 would give you a 0, and we never want a denominator to be 0. So obviously the only critical value you have is -4, and the reason it's -4 is, think about it, this number right here makes this entire fraction become undefined, and so that is one of your critical values. So if my critical value is -4, this is 0, this is -4 right here, my critical value goes here. Notice it is an open point, and I'm going to test values to the left, -5. So if I put a -5 in for x, -5 plus 4 would be -1, so 1 over -1 is greater than 0. -1 is greater than 0, and that is false. Now, I'm going to check this region here, and I'm going to use -3. Well, if I put a -3 here, I will get 1 over 1. -3 plus 4 is 1. 1 over 1 is 1. 1 is greater than 0. Well, that's true. This section here checks. So my answer would be non-inclusive, -4, all the way, continuing on to infinity. There it is. -4 to infinity for number 41. All right, let's take a look at number 45. Now the first thing we want to do is we want to rewrite this equation, or this inequality, with an equal sign. And so we're going to do that right now. Now we want to eliminate all of our fractions, so we're going to multiply the entire equation by whatever the common denominator would be for these two fractions. And we are not trying to find a common denominator. However, if we were trying to find a common denominator, this is what we would use. So we're going to take this fraction right here and multiply it through this entire equation. Well, your x plus 3 cancels with your x plus 3, leaving you with x minus 1 times x minus 4. So I'm going to go ahead and write x minus 1 times x minus 4. Now we're going to take this fraction here times this fraction over here. Your x minus 1 cancels with your x minus 1, leaving you with x plus 3 times x plus 3. X plus 3. Now be careful. Notice there's a minus sign here, so I'm going to very carefully bring down my minus sign and then put x plus 3 times x minus 2 equals 0. Okay, now let's quickly finish this problem. If I multiply these two parentheses together, I would come up with x squared minus 5x plus 4. If I multiplied these two parentheses together, I would come up with x squared plus x minus 6. However, there is a negative sign out front, and so all of my signs would change. So I would have a negative x squared, a negative x, and a positive 6 equals 0. And now notice your x squared cancels with your x squared. You have a negative 5x and a negative x, that's negative 6x, and 4 plus 6 would be 10. bring your 10 over and make it a negative 10, so you're left with negative 6x equals negative 10, and then divide both sides by negative 6, and you would be left with positive 5/3, or 1 2/3. All right, 1 2/3. Now, students, I apologize. As you guys are watching this video, you always see the mistakes that I make, and I hate that, guys. If you were in class, you'd raise your hand and say, Mr. Earhart, you copied that one sign down wrong, which is what I did. But do you see this x plus 2 right here? I put x minus 2 right here, and you knew I would come back to that later, so here's my x plus 2. And so that would give me a positive 5x here and a positive 6x here. Now, I would have x squared minus 5x positive 4, and then your negative sign would change all of those signs. Negative x squared, negative 5x, negative 6. There we go, and now we're moving on. Notice your x squareds cancel, and you're left with negative 10x minus 2 equals 0. And then, of course, if you brought the negative 2 over and made it positive, you would be left with negative 10x equals 2. And then divide both sides by negative 10, and x would equal a negative 1/5. Negative 1/5. So we took our original problem, we set it equal to 0, and we solved, and we got a critical value of negative 1/5. Now, next thing we do is we look at each fraction and we say to ourselves, what would make this fraction or this fraction be undefined? And of course, the only thing that makes a fraction become undefined is when the denominator is 0. So what would I have to put for x right here to make this denominator become 0? Well, a negative 3. So a negative 3 would make this entire fraction undefined. So one of my critical values is negative 3. Now, what would make this denominator become 0? Well, a 1. 1 minus 1 is 0. So one of your critical values is 1. So there are your 3 critical values. So let's quickly put those on a number line. All of these critical values will be closed points. And now let's start quickly testing some values. Shouldn't take too long. Let's first of all start to the left of the negative 3, and we're going to test negative 4. Well, we have a negative 4 here. That's going to be a negative 8 over a negative 1 minus, and negative 4 and a 2 is going to be a negative 2 over a negative 5. That makes the whole fraction positive, and you'd end up with something like, let's see, negative 38 over 5, I believe, which is going to be a negative, let's see, negative is a positive, actually a positive fraction, and so this would be 40. You'd end up with 38 over 5, I believe, but either way it'll be a positive number. Use your calculator and you'll see you'll get a positive fraction is greater than 0, and no positive number can be greater than 0. So this section here, or this region here, does not work. Now let's test the number from negative 1/5 to negative 3. Probably the best number to check would be negative 1. So if we put a negative 1 here, we would have a negative 5, and a negative 1 here would be a positive 2. Minus negative 1 here would be 1, and negative 1 here would be a negative 2. So we really have a negative 5/2, and we have a positive over a negative. That means the whole fraction is negative, and a negative and a negative is a positive 1/2 less than or equal to 0. So we end up with negative 2. If you use a calculator, you'll see negative 5 over 2 plus 1/2 is negative 2 is less than 0. And that is totally true. So we know this section right here does work. All right. Now let's try this section here between negative 1/5 and 1. Let's test the number 0. 0 minus 4 is negative 4. 0 plus 3 is 3. 0 plus 2 is 2. 0 minus 1 is negative 1. So we have a negative fraction minus a negative fraction. So negative 4/3 plus 2 over 1, which would really be a positive 2/3. And a positive 2/3 is not less than 0. It is not less than 0, so this section here does not work. And now we'll move on to testing our last section. Looks like we're going to use a positive 2. And so 2 minus 4 would be negative 2. 2 plus 3 is 5. Minus 2 plus 2 is 4. 2 minus 1 is 1. Less than or equal to 0. We have a negative 2/5 minus, and of course if we got a common denominator it would be 20 over 5. That's going to give you a negative number like negative 22 over 5. And any negative number is less than 0. That's true. And so we know this section right here definitely works. So we have two sections that satisfy this equation. The first one's going to run from negative 3 inclusive to negative 1/5 inclusive, and the other one will run from 1 inclusive all the way to infinity. Okay? And I always check my answers very quickly to make sure they're right, and that one is correct. Okay? Let's go ahead and move on now to number 49. Number 49. Okay, let's go ahead and get started. I'm going to go ahead and do two steps in one here. First of all, I'm going to bring the 3 over and make it a negative 3, and then set it equal to 0. Now let's solve this equation. The denominator that I want to get rid of is x minus 2, so we're going to multiply the entire equation by x minus 2. Now, your x minus 2 cancels with your x minus 2, leaving you with x plus 1. And then when you take x minus 2 times negative 3, be very careful. I'm going to put a negative 3 and then parentheses x minus 2. You always want to be really careful. Oh, and then really quick, x minus 2 times 0 is just 0. You always want to be careful when you see a negative sign in front of this number, and that's why I just wrote it like this. Now it's pretty much a simple linear equation. Negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. And if you combine all of your like terms, you're left with negative 2x plus 7 equals 0. Now, bring your 7 over and make it a negative 7. Negative 2x equals negative 7. And now divide both sides by negative 2, and x equals a positive 7 over 2, which is the same thing as 3.5. Okay, so there's one critical value, 3.5. Now the other critical value should be pretty obvious. You look at the one fraction that you have, and you say to yourself, what makes this fraction undefined? And what would make this fraction undefined obviously would be a positive 2, because 2 minus 2 is 0. So your other critical value would be 2. So we're going to put a 0 here, and a 2 here, and a 3.5 here. Notice both of these critical values would be closed because of the equal sign right here. And now let's go ahead and test some values in each region very quickly. Let's start off with our region over here to the left of 2. Let's test 0. 0 plus 1 is 1. 0 minus 2 is negative 2. Greater than or equal to 3. Well, a negative 1/2 is not greater than 3. So this section here does not work. Now let's test a number between 2 and 3.5. I'm going to test 3. 3 plus 1 is 4. 3 minus 2 is 1. 4 over 1 is 4. 4 is definitely greater than 3. So this region right here does work. Okay, this region right here does work, check mark. And then if you test 4 over here, the number 4, I don't believe that works. Let's see real quick if it does. 4 plus 1 is 5. 4 minus 2 is 2, so you get 2.5 is greater than 3, and that is not true. So only one region worked. It's this one right here. It would be 2 inclusive, 2, 3.5 inclusive. Okay? All right, let's move on to number 53. We're almost done. 53, 57, and 61. So just 3 more problems and we're finally finished. Okay. On number 53 here, I'm going to go ahead and do 2 steps in one. I'm going to do a bunch of steps in one. First of all, when I copy this fraction right here, I'm going to go ahead and factor it. So my denominator is going to be x minus 3, x minus 1. Then I'm going to bring this fraction here over to the other side. So it's going to become a negative fraction. And when I write this fraction, I'm going to go ahead and factor the denominator into x minus 3, x plus 3. And all of that will be less than or equal to 0. But actually, I'm going to go ahead and set it equal to 0. So equals 0. Now, the common denominator for all of this would definitely be x minus 3 quantity squared x minus 1. And the reason it's quantity squared is you say to yourself, how many groups of x minus 3 do I have in this denominator? 1. How many groups do I have in this one? 2. Which one has the most? This one, and it has 2. So that's why we use x minus 3 squared. Now let's multiply this fraction here times this fraction here. Notice my x minus 3 will cancel with one of my x minus 3's, leaving with 1. And then my x minus 1 will cancel with my x minus 1. So I'm left with x minus 3 times 2. X minus 3 times 2. Now, next, notice I have x minus 3, and actually, boy, I did make a mistake on all this, didn't I, guys? I'll tell you what, you can tell I'm on a home run tonight here, guys. I do apologize, but actually my common denominator for all of this would be we have one group of x minus 3, one group of x minus 1, and one group of x plus 3. So my common denominator would be x minus 3, x plus 3, and x minus 1. And I do apologize. Okay, here we go. X minus 3 and x minus 1 would cancel with x minus 3 and x minus 1. So you're left with x plus 3 times 2. 2 times x plus 3. Now, your x minus 3 and your x plus 3 would cancel with these two, leaving you with x minus 1 times 5. Now be careful, there's a negative sign right there, so really watch your signs, okay? I would actually put a negative and then a 5 and then your x minus 1 equals 0. And now we can solve this pretty quickly. I would have 2x plus 6 minus 5x plus 5 equals 0. If you simplify, you will get negative 3x plus 11 equals 0. And then you would be left with negative 3x equals negative 11. Divide both sides by negative 3, and you will get 11 over 3, which is 3 2/3. So we have solved the equation for one of the critical values. Now the other critical values will be pretty simple to find. If we remember, the factorization for this denominator was x minus 3, x minus 1. So what would make this denominator undefined? Well, a positive 3 would make it undefined, and a positive 1. So there's some more critical values. And then also, what would make this denominator here undefined, or this fraction? Well, the factorization was x minus 3, x plus 3. And of course, that means that positive 3 is one of the numbers that would make this denominator undefined, and also a negative 3. And we already have a positive 3, so we're just going to add a negative 3. So we have here 4 critical values, okay? 4 critical values. So very quickly, I'm going to plot those on my number line here. We have 1 over at negative 3. And then we have 1 at, let's see, 1, and then 3, and then 3 and 2/3. Now, risking sounding a little lazy, guys, a lot of this is calculator work, and so what I'm going to do is show you which sections work. If you were to test a negative 4 right here, you would get out a true statement. I'm not going to take time and put a negative 4 here and square it. 16 minus 4 and all of that. That's just calculator work you can do on your own. This is a really long problem with all of these powers and denominators. So I'm going to tell you now, this segment here, this section here would check. This section right here, going from 3 to 0, this would not check. You would check the number -1 more than likely, and it does not work. Actually, I would test the number 0, and 0 does not work. And then from 1 to 3, I would probably test the number 2. And if you test the number 2 does work. So this segment here checks. And then going from 3 to 3 and 2/3, I would probably try 3 and 1/3, which is the same thing as 10 over 3. And if you test 10/3 using a calculator, of course, you will get out this is not a true statement. And then of course, using the section here to the right, if you tested the number 4, you would see this section here does check. So we have 1, 2, 3 sections that work. One section is bounded, the other 2 are unbounded. So for this region here, it would be negative infinity going to -3. And by the way, all of my points should have been closed, so I'm doing that now because of the equal sign right here. So negative infinity to -3, and then from 1 to 3, and then from 3 and 2/3 to infinity. All right, there we go. Okay, moving on now to number 57. Number 57. Well, I'm going to go ahead and factor this denominator and pull out x. I'm left with x plus 3, and then bring this fraction over, make it a negative fraction. -3 over 2x plus 1 equals 0. Now I'm going to slide this over and get a little room here. I'm going to multiply this entire equation by x plus 3, 2x plus 1. And let's see what happens. First of all, your x and your x plus 3 would cancel, leaving you with this times this. So I'm going to write 5 parentheses 2x plus 1. And then your 2x plus 1 would cancel with your 2x plus 1. Okay? So you're left with a -3 times your x times your x plus 3. Now, take your 5 and multiply it through. You're left with 10x plus 5. Now take your x times x is x squared times negative 3. That's a negative 3x squared. And then your x times your 3 is 3x times negative 3. That's negative 9x. So we have a quadratic equation, which is not the end of the world. So we're going to write negative 3x squared and then positive x and then positive 5. All right? Equals 0. Okay, I quickly paused the video to save you guys time. We're left with the quadratic here that cannot be factored. And so if you use the quadratic formula, I'm just trying to save you time and save the video time. The only way to solve this to get the zeros is to use the quadratic formula. So if you do that correctly, you're going to come up with this right here. 1 minus the square root of 61 over 6, and also 1 plus the square root of 61 over 6. So I'm going to grab a calculator real quick and type in those two numbers so I have a decimal. And for this fraction here, I'm getting negative 1.14. And then for this one here, I'm getting, let's see, 1.47. Okay, so there's two critical values right there. And now the only way to get the rest of my critical values would be to ask myself what makes each fraction undefined. Well, for this denominator here, it looks like to me it's going to be 0 and negative 3. So 0 and negative 3. And for this denominator right here, if you were to put a 1/2 in right here, a negative 1/2, 2 times negative 1/2 is negative 1. Plus 1 is 0. Now, if you're not sure how I did that, just take 2x plus 1, set it equal to 0, and solve, and you'll get negative 1/2. So another critical value is going to be negative 1/2. So let's quickly plot these on our number line. We have 0 for one of our critical values, negative 3, and negative 1/2. And actually, I should have slid that down a little bit. So let's go ahead and do that real quick here. Put a negative 1/2 here. And then we have negative 1.14. And then we have what? 1, 2, 3, 4. A positive 1.47. Okay, so just real quick, if I were to test a number to the left here, it would be negative 4. If I were to test a number here, I'd probably test negative 1. If I were to test a number here, I would probably test negative 0.2. And if I were to test a number here from 0 to negative 1.14, it would probably be negative 1. And then between these two numbers here, I would test between 0 and 1.47, I would test 1, and over here I would test 2. Now again, to save time, the regions that do work on this right here would be from negative 3, let's see, to and I see now what I've done wrong here, guys. I should move these two around right here. So there we go. And there we go. Okay, that's a little better. Now the regions that do work are going to be this region right here that runs from negative 3 to negative 1.14. This region checks right here. That's good. This one does not, but from negative 1/2 to 0, that one does work right here. That's a check. And then lastly, this region here does not work, but this one over here does work if you tested those numbers. So one answer, notice all of my points are open. One answer would be negative 3 to 1.14 exclusive. And then another region that works would be right here from negative 1/2 to 0. And then the last section that works would be from 1.47 to infinity. Okay? So I am trying to save a lot of time on these. I'm not being lazy. A lot of these are just calculator problems where you take a number, you substitute it in, and you check it and see if you get a true or false statement. And we're just trying to quickly bypass that to save some time. Okay? Well, number 61 looks like it's a little tough, but let's quickly knock this out. And that's the last problem on the video. So that's good news. Okay? Let me get a drink here real quick. And let's go ahead and do some factoring. For right here, I'm going to have x plus 5, x minus 1. And for this right here, I will have x plus 5, x minus 5. And for this denominator right here, I would have x minus 5, x minus 1. Okay? Well, it looks like I'm going to, first of all, I'll erase all of this later, but it looks like I'm going to have to make this a negative sign and then put equals and then 0. And then I'm going to have to multiply the entire equation by, let's see, x plus 5, x minus 1, and x minus 5, all of that over 1. So here we go. When we multiply this fraction here times this fraction over here, your x plus 5 and your x minus 1 cancel out, leaving you with x minus 5 times x. So x times x minus 5. Now I take this fraction here times this fraction here. Your x plus 5, x minus 5 cancels with your x plus 5, x minus 5, and you're left with x minus 1 times 3. So x minus 1 times 3. And then when we multiply this fraction here times this fraction here, x minus 5, x minus 1 cancels, leaving you with x plus 5 times 2x. But notice there's a negative sign here, so it's really negative 2x times x plus 5, okay? And all of that equals 0. So let's quickly simplify. Here we go. I would have x squared minus 5x plus 3x minus 3 minus 2x squared minus 10x equals 0. Now if we combine, we're left with negative x squared, a negative 2, a negative 12x, and then a constant term of, let's see here, I believe a negative 3 it looks like. Now again, I paused the video, did a little work here, and you cannot factor this, but if you use the quadratic formula on this, you will get out this right here. You will get out negative 6 plus the square root of 33 and negative 6 minus the square root of 33. So let's quickly get those into decimals so we can put them on a number line. So negative 6 plus the square root of 33 will give you negative 2.56, negative 0.26, negative 0.26. And then if you take negative 6 minus the square root of 33, you will get negative 11.74. Negative 11.74. So we're doing pretty good. I mean, there's a couple of our critical values right there. And now, just look at each denominator. I mean, we know that negative 5 would make this denominator 0. Also positive 1 would. Also negative 5. Also positive 5. Also positive 5. Also positive 1. So really, our critical values are going to be 1, negative 5, and positive 5. So here's 1. Here's 5. Here's negative 5. Let's see. 1, 5, negative 5, and then negative 0.26. So that would be about right here. Negative 0.26. And then way over here is going to be negative 11.74. Okay? All right, now I would test negative 12 for this region. I would test negative 6 for this quadrant. I guess I should have put a circle right here. There we go. I would test negative 1 for this section here. I would test 0 for this section here, 2 for this region here, and 6 for this region here. Okay, now let me quickly look at the work that I have here. I'm trying to save a lot of video time. If you were to test these quadrants, this one here would not work, but this quadrant right here would work. So a check mark right here, that one would work. Okay, and then from negative 5 to, let's see what we have here. This region right here would not work. I'm looking at my work carefully. And then this region right here from negative 0.26 to 1 would work, so a check mark here. And then the region from 1 to 5 would not work, but this region right here would work, so check mark. Okay, so we have 3 different sections for our answers. So this one over here, and by the way, I'm trying to look at the original problem to see if it was an equal sign right there. So all of these points should be closed points. So this region here works. So we say from inclusive negative 11.74 to negative 5. And then this section here, which would be from negative 0.26 up to 1. And then we have from 5 to infinity. Okay, so there's your answers right there that resemble those regions or sections that definitely worked. Okay, so pretty long video like I knew it would be. However, it's only homework and that's it. And so I hope this homework help video was a help to you. Call or email if you guys have any questions.